Hi, I'm Kyuhan, creator of Computational Thinking Pattern Analysis. Computational Thinking Pattern Analysis, also known as CTPA, is the first automated computational thinking assessment tool for visual programming languages. So far, the CTPA shows the final state of a given agent sheets or agent cubes project. For example, when a student finished programming his or her project and submitting it to the arcade, then the CTPA shows what kinds of computational thinking patterns are used to implement the project. This is an actual example. This is a game of Sims, and when a student finished programming this Sims game, he submitted to the arcade. This arcade is our online repository, as also works as our cyber learning infrastructure. So the CTPA analyzes a given game and visualize its semantic meaning through a phenomenology. And if there is any tutorial, it compares the tutorial and the given game. This showed only the final state of a given project, but now CTPA works in real time to analyze every single user programming behavior. This is a demo video of real-time CTPA. This is a game of Frogger designed with 3D visual programming tool, Agent Cubes. This is 3D. Agent designs are done. All agents are, the design is done, but no programming yet. I will show how the real-time CTPA works with actual programming. This graph shows the CTPA graph for every single condition or action. And this graph, it will show the CTPA graph for this graph will show how 9 computational thinking patterns, how they evolve over time. So I'm gonna make one pattern which is called collision. So collision in this game of Frogger, when frog sees truck, its left side or right side, then it is changed to a dead frog and is erased. So the first condition will be C. So if I see the truck, my left side, then it shows what kind of patterns are there. But I didn't complete any single pattern, but there is the patterns here because it is a part of those 5 patterns. So that's why, and then this C condition, it is not a part of this causal control, hill climbing, diffusion, or transportation. So that's why there is no value for those 4 patterns. And I'm gonna change myself as a dead frog. So the graph is changed, is also changed. So now the collision goes up and absorption goes down because this is more close to collision pattern rather than any other patterns. So I said I'm gonna change myself to a dead frog and I'm gonna be erased. So the graph is changed again, and the draft value of absorption, it goes up again, and actually it is a little bit slightly higher than collision. And I'm gonna show why it is like in a couple of seconds. And I'm gonna put weight between change and erase. That is the most common way to implement collision pattern. and now the collision equals up again, and absorption is still high, but it is below collision. So I'm gonna implement absorption pattern for truck. So absorption pattern for truck in this game, it is when this truck sees this right tunnel, then it will be erased. So here absorption pattern is higher than the collision pattern because absorption actually it is a sub pattern in programming point of view. Sub pattern of collision because there is C and there is erase, and absorption pattern it requires only one action and one condition. So that's why like this.